So it's like integer index. You can give each names.
Okay. So then, essentially, you can return more than just a single type.
Yes. You can return more than, well, technically no. Because a tuple is in of itself.
In itself,
a type.
its own type.
Yeah, that's right. Okay. But you can return compound values. That's what you call it. Okay. Compound type. Perfect. Values of compound types.
Gotcha.
In the near future, we'll be returning instances of classes, which also have many values to them, and arrays and dictionaries.
Cool.
It's going to be a smorgasbord of return values. But for now, we will stick to the basic types that we know. I think I've only encountered a couple of times when I needed to return a tuple, actually. And I probably ended up not returning a tuple because I wrapped it in a class instead, just because it made it more convenient to do stuff to it.
Sure.
So I don't know how common they really are.
Okay.
But it's a structure that is common in other languages like Python, for example.
Yes.
They're not very common only because of how you structure your data.
Exactly.
But like an example, say for instance, when the first time I used it was in a tip calculator. So you give a dollar amount and you divide a percent, and it gives you back what the tip percent is and what the dollar amount plus that tip percent. So in that situation, I use a tuple to return two values.
I'm just thinking like a data object from an API call, like JSON call, you're going to get mixed. If you want to run a function on that return data object, that's not always going to be an integer or a string. If you want to extrapolate out of that.
Yeah, that's you'll get to that when we're using JSON. That's actually a totally different type that we're not covering right now. It will be like it's actually as a dictionary, and then for every value in the NS dictionary, you actually have to then say this is an int, this is a.
Gotcha.
You come across that.
Oh yeah. It's coming. It's going to be so much fun. Okay. Any other questions about how these functions are working? We're accepting strings, we're accepting doubles, we're returning doubles. The value of the function call is the type that we declare in its definition. Things like that. Okay. So this is of the spirit of Swift right here. This is declaring explicit types so that Swift's compiler, a little program that runs in the background in the playground, is turning our human-readable code into that like low-level binary code that runs really fast on an iPhone. This gives it the information it needs to make that code fast. Because since we've taken away the step that Swift would normally need to check if something's a double or not, it can bypass all of that and just go straight ahead and execute our code instead of saying, whoa, 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 whoa. Is that an integer? Is that a double? Is that a string? Is that X, Y, Z? And going down the list. So that's why we have to do this. And but what it means is that you'll have to be very aware of the types of the values that you're passing around, the types of the variables that you're declaring, and the types of arguments and return values. So all going to be about types. Types. Even function is a type to some degree. So what I wanted to show you a little bit here is a little bit of flexibility around functions and how we can use them. So what I would like to do is replicate the experiment that we did earlier where we took a conversion value or some conversion steps, from kilometers to miles. Okay. So let me get rid of this. All right. So this is the example we had before. So what we're going to do is take this logic and turn this into a function so that we can treat this conversion in a Sean, give me a function name that is of the same spirit of conversion. So we want the function to convert kilometers to miles. So should name the function be
Kilometers per miles.
kilometers what?
Per miles.
Per miles.
Or we want to convert kilometers to miles.
Right. Convert kilometers to miles. Yeah. Somewhere I read that kilometers is actually the right pronunciation. So
Not in America.
Not in America. So I'm tripping over myself, trying to like train myself to do that, just because I'm.
We gotta say kilo, makes sense.
Yeah, kilograms. We don't say kilograms, so kind of makes sense there. All right, convert kilometers to miles. So I'm trying to convert kilometers to miles. So if I'm trying to replicate what I have up here, but in this case, instead of defining a variable, I'm going to define a parameter. What should I be typing next to declare that parameter? Allison. What am I going to parameterize my function on?
Kilometers and miles.
Kilometers and what was the second?
Miles.
That's right. So, but miles is going to be not my parameter, but miles is going to be my what? Remember the term we used before to describe, what's the keyword that I would use to make a function spit out a value? Remember? It's in your code. This one. Can you see it?
Alright. Return.
That's right, return. So my return value is going to be miles. So what should which of miles or kilometers is going to be my parameter? Do you think, logically?
Which one?
Which one?
Kilometers.
That's right. So I would type kilometers, and then what?
And then I guess the type.
That's right. How do I do the type? You've already answered this question once.
Yeah.
This guy, right?
Colon and double.
Double. Excellent. All right. Raj, what am I missing here? What's the next thing that I should do? If I'm writing a function to convert kilometers to miles, kilometers is my input, miles is my output. So we're going to return what's missing in this spot here that gives a cue to Swift as to what I'm going to return.
We need to write return.
Right, but I'm going to write return later. Well, what do I do right here? Right, I have a brace already, but there's something missing from here. I have to take a value, the arrow. Right, what comes after the arrow? The type. Right, the return type. This is what we call the return type. What's that return type, Ned? Come on, there's only one type on the screen. Double. I'm going to go from kilometers to miles. Kilometers is going to be a double. Miles is going to be a double. My input is kilometers, therefore my input type is double. My return value is going to be miles, therefore my return type is going to be double. Does that make sense? So this is very template-like. I'm only talking about, on line 55, I'm only going to talk about types. But these are my inputs, and this is going to be the type of my output. The only difference in this case between inputs and outputs is that inputs have names, and outputs don't. So I never give an identifier over here, it's always over here. Okay, so I'm going to convert kilometers to miles. Art, do you have any idea what the next line might be?
Return.
It could be return, indeed. So let's pretend I actually don't have any of this up here. Let me comment that out.
Can you tell me again how to do that?
Oh, that little trick?
Why do you click on it?
That is command slash. So right next to each other, down below, command slash. Love this keyboard shortcut. It's like my favorite keyboard shortcut. This is the keyboard shortcut of frustration.
That's not your favorite.
It's not? Oh, what did I say my favorite was?
Everyone's favorite is cut, copy, and paste.
This, oh, yeah, we're going to try to dispose that from our repertoire. All right. So I'm trying to convert kilometers to miles. Let's say I want to encapsulate that whole idea inside the body of this function. So in order to make this conversion work, I need to know how many miles are in a kilometer. Right? So what should the next line be, Aaron?
Yeah, you want to return the 0.62. Well, so the miles per kilometer.
That's right.
So is that existing or is that not existing?
Well, since I've commented it out, nothing's existing. So,
Okay, so 0.62 times the kilometer.
okay. Let me skip to the punchline, and I'm going to just copy this line. I'm going to try to do something descriptive, but I want to show you that functions can actually have multiple lines in their body. All right. So in this case, what I want to do is say let miles per kilometer equals 0.62. And then what I'm going to do is say let miles equals this. Then I'm going to say return miles. I think I realized that I actually can't come up with a series of questions to get to exactly what I want. So, all right. Okay. So in this case, all this logic will be executed at call time. But I'm writing it out like this, mostly because I want to show you an example that has multiple lines in the body, but also really long variable names. Right? So this is logic that starts to describe exactly, step by step, what I'm doing. I have a constant here, miles per kilometer, 0.62 miles per kilometer. Which does one thing. Right? All it does is say what miles per kilometer is. And then here I have the number of miles equals miles per kilometer times kilometers. Kilometers is one of my inputs, so this just does one thing. This computes the number of miles that I have. And then this one, line 58, returns miles. I can almost read this like English if I wanted to, because of the names that I've picked, and because of the fact that I have written every single operation out on its own line. So this is a design principle that we're going to try to stick to and adhere to. It's called the everything does one thing principle. So a function that you write does one thing. Every line in that function does one thing, etc., etc., etc. It's a great way to start organizing code, because you're quickly going to come into this state where you're going to start writing lots of code. And so if you can really break down a problem like this into individual steps, it'll help your code writing immensely. So you can just focus on one thing at a time. Yes.
So I just want to reiterate that because I've already heard a couple of times this idea of like shortcutting things. That's actually bad practice in iOS, specifically in Swift. It's actually bad practice. In the future, you'll see how writing all this extra stuff is actually helpful, because in your debugger, it'll tell you the values of those individual variables step by step in your code. So, whereas in the web world, I would put everything in one line, the less lines, the better. When you're actually programming Swift as a Swift programmer, you definitely want to follow this mantra. So it's not just for this course. Really good developers do it this way, which is a totally different mindset than like the web world. I don't do this on the web. On the web, it's one line and that's it. But there are a lot of added features that you'll come across, especially when you're debugging your code, that you can only take advantage of it if you actually do it this way.
It doesn't mean necessarily, though, it's a great point.
But it's not bad.
I'm sorry?
Putting everything in one line is not bad.
No, it's not bad. No, it's just, the environment that you're in Swift helps you understand your code better, especially when you're debugging. Having to explicitly declare types actually helps a lot, because you need to know what you're dealing with and what the semantics are of those two things when they come together. But the one line, everything does one thing principle doesn't necessarily mean that you're taking mathematical expressions and breaking them out all the time. So, like converting Fahrenheit to Celsius, for example. It's Fahrenheit minus 32 times 5/9. I wouldn't actually break that out. I wouldn't actually say like, oh, first part equals Fahrenheit minus 32. Like I wouldn't do that. Like because the math equation is well defined. But I would write out like Celsius equals Fahrenheit minus 32 parens times 5.5/9. Return Celsius like that. Like I would just go ahead and write that out. Probably a little lazier now about that than I should. Do as I say, not as I do. No. So I'm going to finish the example here by calling the function with a value whose result that I know. So convert kilometers to miles. I don't know. Is it going to work? Did I do something wrong?
Yeah. Nothing wrong. It's
Did
just
nothing
not going to
wrong.
show. Do you have a spinner?
I have a spinner.
You didn't do anything.
I didn't do anything wrong. Swift started to do stuff wrong. Can I save it before it dies? Anyway, you have a question, Art?
Can you have the constant outside of the function?
You have the constant outside of the function. Yeah, let me show what that means in a second. Once I get out of this state. You see, this just reinforces that we're all in this together.
Oh, no, that's all part of the course as well. Every time the computer freezes on Will and every time he gets frustrated, that's all part of the course.
That's right.
To give
It's
you
all
the real
planned.
experience.
That's in my script right over here.
To give you the real experience so that when that happens to you, you'll know that it's normal.
Yeah. I think that's probably a good point. Alright, so here's the functions demo. Oh, I already have it, so I'm going to call it. Maybe it'll work for me now?
Yep.
Alright, excellent. So go ahead and convert a bunch of kilometers to miles. Values that you would have never thought of before to convert. Like the distance from the Earth to the Moon, I guess.
Don't go, Will.
Sorry?
Don't go too crazy.
It's okay. Right, oh, because of Mr. Spinner?
Yeah.
Why does it work now and didn't work before?
Because the playground just crashed.
Yeah.
You know what I think it is? I think that it has something to do with like having multiple playgrounds open and all the compiler instances sharing.
Oh, they're all
space.
compiling at the same time.
Yeah.
This actually happens sometimes where there's like no error and it's not too
All right.
enough.
So
That's exactly what
alright.
happened today.
Okay.
So,
How many playgrounds do you have open?
all right.
Just this one right now.
Save this. And then just close everything. No, Atlas completely shut down all of this stuff.
What's that? Sorry.
Okay, I'm gonna open it up again. Make sure
This number is the average distance from the Earth to the Moon in kilometers or kilometers, and thus it's equivalent in miles.
Floating away.
Okay, so now you give me.
Yes, the rate of like a couple of centimeters a year or something, or like centimeter a year. Yeah, it's like slowly.
It's millimeters.
Sorry, millimeters a year. Millimeters a year. Just slowly like backing off.
It was so close.
Yeah, it was so close, a billion years ago.
And it was like 2 miles. Flux and flux.
Oh, really?
At the beginning.
That's crazy.
Everything washed.
Interesting
That would
fact.
take a lot.
You can squeeze all of the planets between the surface of the Earth and the surface of the Moon with distance to spare. This is what I've been told.
Say that again?
I think that if you added up all of the diameters of all of the other planets, that value would be less than 384,000 kilometers.
Including the sun.
No. Planets.
Wait, that can't be right.
Can't be right. We should be able to prove it using Swift. No, we won't do that now.
After all.
Yeah, right. It's just a bunch of addition. I think calculator could probably handle that. All right. So is everyone understanding how this works? Like understanding the flow from like the call site, taking a value, assigning that to the variable kilometers, using that value here, computing something and returning a value of this type out on the other end. It's complicated. And it starts to become more intuitive the more we start.
Can I reiterate something?
Absolutely.
This is 99.9% of the rest of the course. Functions. 99.9%. So whatever questions, doubts, trust me, you want to ask them now.
Could we use, instead of let minus equal variable?
Yes. Yes, you can.
What's changing then?
It's not changing when it doesn't change when the function is called, like inside this thing here. The reason why I might use var instead of let is if I had to do more stuff to miles afterwards. That makes sense?
You leave it open.
Yeah, let's say it wasn't just kilometers to miles. Let's say it was something really complicated that went through several steps of conversion. Like, some really complex chemical process, and I was calculating molar volumes or some craziness like that. And I had to just boom, 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 and keep adjusting that
So
variable.
the miles can change during that reiteration.
That's right. So if it were to change. So it's at the stage we're at in terms of the code that we're going to write, it doesn't really matter, but in terms of your learning, it does matter. So I would encourage you to really think about, like, is this thing ever going to change? And then what will happen is you're going to think that something's not going to change. You're going to try to change it, and then you're going to start to realize, oh, well, how did my logic change? Like, why do I have to change this now, where I originally thought that I had to keep it the same? Like, and that's a good thought process to start to get into, I think. So, yes?
Can you ask a function within a function?
Yes, you can. So there are tons of things that we can do. So one thing that we should start to go over right now, if there are no other questions about this basic way functions work, is this notion of scope. So any other questions about? Yeah.
Oh, you're going to talk about scope?
I'm going to talk about scope. I'm going to start talking about scope. Okay. So there's this notion called scope. And scope is the lifetime of a variable, or the places where variables are available and functions are available. So, for example, this constant miles here, if I were to type miles out here, it would give me an error. Use of unresolved identifier miles. So what that means is this identifier, it can't figure out what this refers to. I used MILES, but it's not a variable, it's not a function, it's not a constant, like I don't know it's not a type. Like I don't know what you mean. But I declared it as a constant here. So what's the dealio? The problem is that any declarations that occur inside a function body stay in the function body. This is Las Vegas. Whatever's declared. Angel didn't see that.
No.
This is Las Vegas. Anything that's declared in here stays in here. All right.
And
So,
then, can you use it again?
use what again?
Miles. Can you define it again? Outside?
Outside? Oh, absolutely. So now I can say like var miles equals 0. Miles plus equals 2 miles. I can do all my if miles equals blah. I can do everything after that. But what it means is that on line 66, miles begins to have meaning, and then afterwards it has
Stay that way.
That's right. Okay, so this comes back to Art's question, which is, can the constant miles per... Yeah, I'm going to totally check out that crash log. That's what I live for. So, problem here, or the question here is, miles per kilometer. This is a constant. In fact, it's like a constant. Like this is a dimensional constant. Never ever changes ever. So the question, the real question is if I were to declare this outside of this function body, but instead of putting it way down here like I did miles, put it up here, would it still be valid inside the body of the function? Let's test and see. Is it still working? Yes, it is. So this kind of reasoning, this kind of phenomenon, falls under this notion called scope. So I just altered the scope of this constant miles per kilometer. Instead of the scope only being restricted to the body of this function, now the scope is line 54 and everything that comes after it, including bodies of functions. Does that make sense?
So now it applies to everything.
It applies to everything afterwards, so
including the function.
including the function. That's right. So the notion is that anything that's declared on the outside of braces, of function bodies, rather, applies to the inside of those function bodies. Yes.
It doesn't matter if it's variable or constant.
Aha, does it matter if it's variable or constant?
Matters.
Yes, it does. And I'm going to show you why. Because of this nasty little phenomenon. Now, this is usually something that we'll go over later. But it comes back to Raj's question when he was asking about, well, like we say that each successive call, like kilometers, is going to be a different value, and it never remembers the value that it was before. There are ways to get functions to remember values. So if I have a variable, it's a good make this an integer. And then there's another question the parent had. Can I nest functions within functions? Yes, you can, but I'm not going to show you how to do that today because I think it's one too many concepts. Because it's part of a larger body of concepts where you can actually use functions as arguments. But what I am going to show you is calling a function that you have defined within another function that you have defined. So in this case, I'm just going to say convert. And I'm going to say, say what? I'm going to say string, and then value double, returning a double. Convert, let's say convert to imperial instead of just convert. I'm going to say return. Let's see. Is this too complicated, do you think?
Might have been a bit more conceptual if we did miles to feet, so that we can call
At the same time?
yeah. That'll work too. But
Miles to feet. This also gets us multiple return statements inside one function, which is good. Oops. Might do it. Maybe I'll do like some random numbers, like 7, 9, 11, to not conflate the values. Okay. Just let you all type that out if you like. We just went next level with this one. So don't be too scared. At 8:45, we're going to switch over to the activities we have. 6 minutes. All right. you haven't finished typing, that's okay. Just sort of look up, and I'm going to explain what's going on. So, convert to imperial. What I'm trying to do is create a function that does more things for me than it should. This is not necessarily good practice. But it accepts a string that asks me what I'm trying to convert, with the idea that I can give it kilometers or some other thing like some other unit like Celsius or grams, and it will automatically convert it to the most likely equivalent value. So kilometers to miles, grams to ounces, etc., etc. So, but the first argument or first parameter is going to be what I'm going to convert. So, what is a terrible parameter in my mind? And then value is going to be the actual value I want to convert, and it's a double. Skip this line for a second. So the if statement, all it does is say if I've entered kilometers, then call the function that I defined before. So the scope of this function is the same as the scope of that constant that I had at the top, kilometers per mile, miles per kilometer, up at the very top. So functions, like variables, have scope, and that scope behaves exactly like variables. So this function is now available to me inside the body of this new function that I've written farther down on the list. So anywhere below convert kilometers to miles, I can use it wherever I want to. So that's one.
Wait, is that convert kilometers to miles related to?
That is the exact function up here. That is this guy. So now I'm using it. So your functions can depend on other functions that you have written. Does that make sense? I'm returning 0.0 here, bad policy. This is a scenario where an optional would actually be better for me. But we can get to that. So, the question that we're trying to answer is, does it matter if I'm using let or var in a variable that's used inside of the function, but that variable or constant is declared outside of it? Number of calls is equal to 0 to start out. But when I call this function, it's going to increment number of calls by 1. It's going to say whatever that value is, add 1 to it. I call the function 1, 2, 3 times. And look now, the value of number of calls is 3. But I set it to 0. Right? This, it's called a closure, this phenomenon is called closure. I've taken whatever variable was outside here and I'm using it in here. But it retains what we call, we say it retains its state, which means that this variable, number of calls, is the same number of calls, with the same variable every time this function body is executed. So the function is actually changing this value outside of here. This is very dangerous. This is something that you want to be aware of and be in control very tightly. Which is why I recommend that you be very explicit about using let or var, whether you want something to change or whether you don't expect it to change. Right? So use let liberally and use var carefully. Alright? So in this case, if my intent were to count the number of times I was calling this function, then this kind of makes sense. Number of calls, I've named the variable what I expect it to be. I expect it to change because it's a var, it's changing, and I'm using the value to check myself. But if I don't expect it to change, and I've written assignment statements, like if I've written a statement that says, take this value and take this variable and assign a value to it, if you're closing that value like this, you might be changing something that you don't want to change. This falls into a realm of, this falls into a paradigm of programming, functional programming. And it's really interesting to get into techniques like this, I think. But you have to be very careful. So, it matters in two respects. It matters because you are declaring in one sense what you expect using let and var. But also you could be accidentally changing something that you don't really want to change. And by using let liberally, Swift will warn you when you try to change stuff. Okay. Any questions about how that's working? This is a bit of next level
So
kind of stuff.
every time the function runs, because you call it, that number of calls increases with 1.
That's right.
Basically what happens.
That's right. And it's because its scope is outside of the function body that it's retaining its state, that the value stays the same. Because there's only one of them. Right? There's only one number of calls sitting there. That variable only exists in one place. And I'm doing an operation that changes it.
So if you put that variable number of calls equals 0 inside just before number of calls, then it will not change.
That's right. In fact, it doesn't change. Well, it changes once.
Once, right?
But it's no longer available because I've changed its scope. Right? Now its lifetime is only between this brace and this brace right here. Okay. The other thing that I want to point out is I've used the return keyword twice. So the return keyword is similar to break. Remember break that takes a loop and aborts and starts executing afterwards? Return is something that has a very similar behavior. Whenever you reach return in a function, function stops executing, grabs that value, returns it, and it's done. Okay? So you can use return to break out of a function early if you want. You can control how the innards of a function are being executed by careful use of the return keyword, etc. and so on.
I have a question. What happens when you copy line 72? Well, no, copy it, don't paste it.
Yep.
Copy line 72 to line 68.
Ooh, indeed. What's going to happen? 0. All right, so here's what happened. This variable was defined with the outer scope, but in this new scope, I'm redeclaring this identifier, number of calls, and I'm setting it to 0. So notice how it never equals 1. In the end, it doesn't equal 1, even though I say n plus equals 1. It's because this number of calls is not this number of calls. This number of calls is this one. So inside the scope, everything local reigns. So everything that happens in the inner scope is what rules the inner scope.
That's why I don't do that.
Yeah, you don't want to do that.
Also, you'll notice that you don't get an error because you're basically creating the same variable twice. But the reason why that works, like we said, is because you're declaring it within a different scope, and that's okay. So doing that right there is bad because you're declaring the same variable within the same scope. At this point, you can say it's the root scope. So that iOS won't let you do. But the one on line 72 is a different scope. But this is all like high-level stuff. Don't have to remember. There won't be any quizzes on this.
Yeah, there won't be any quizzes on this one. But I think it does demonstrate a point that it's really important whether you say let or all.
Plus, this is a good way to catch bugs. If you make the mistake of using variables in this way, like you did it unintentionally and you're not getting the results that you want, understanding this will help you debug your code.
That's right.
Is there a way to embed checks? So in line 86, if you say if number of calls does not equal the sum of, not the sum, but because 82 through 84 we do call it 3 times. So if
I would just say 3. I would probably do it like this. But yes,
but that 3 could change depending on how many times you call it.
Yeah. So it's a really great point because what you're actually saying is that there's code that I can write in a debugging process that helps me check the real code.
Yeah.
Now, if I were to extend that into a professional setting, this would be a test that I would write to ensure that what's going on in my code is what I expect.
Okay.
So in this case, I would probably wrap this whole thing in a test and call it 3 times and make sure number of calls is 3, right?
Yep.
And then I would fail or succeed. But the thing that I would be testing here would be the logic around number of calls.
Okay.
In assuming that that was important somewhere else in my app. So say I was counting the number of times that a user tapped on a button or something, and I was trying to compare that with the number of web requests that I had initiated.
Yeah.
Stuff like that. Stuff like that.
Okay.
Or more common like in a game where you can only, perform a certain amount of tasks under certain conditions.
Yep.
You want to be able to measure that, kick 3 times and that's it.
Okay. That's not something that would be like throughout the entire code base. It's just sort of like side checks to make sure it's.
Yeah.
Yeah. Okay.
In fact, I think it was Zoe that asked what does 2 targets mean when we're looking at Xcode? Because one of those targets is the test suite.
Okay.
And one of those targets is the actual app. So I'd be writing code. Good coding practice would be writing code in parallel. And if you all are curious about that later, I can show you Hackulator and all the tests that I wrote to test the computation engine. There's no way I could have ever written that app without a huge set of tests to test the
Yeah.
test it. So.
Isn't it a good practice to have like a return or print line to show that the function is actually executing
As a debugging policy, absolutely, yeah. As a format debugging, as they say. In practice, in a production app, I would try to remove as many print line statements as possible. And I would actually use another library that is a crash reporting library, like Crashlytics or something, that would collect a bunch of debug statements, wrap them up in a text file, and email it to me if an app crashed, stuff like that. So print line statements are great when you're actually developing, but once you start to push that app out into the world, I would remove them, or use a different mechanism to store those messages if they were important. Print line statements, you generally wouldn't want to use print line statements in really fast-running tight loops that run millions and millions of times, because now you've got millions and millions of print statements going out. It can also slow your app down while you're running it. All right. So you should all sync your repositories. I changed the name of the file, because I'm doing that. That's my mojo. And in lesson 5, there should be a playground called Lesson 5 Homework Exercise. If you open that up, you will see this. There's a preamble that's a lot of writing, which starts on line 5 and goes all the way to line 59. This simply reiterates everything that we just did, except for the last part about closures and closing values. But there's a series of exercises that I'd like you to attempt here in class right now, in pairs, as usual, for the next 40 minutes. And Angel and I will make sure that everything is going okay. So, ideally you would partner with someone with whom you have not partnered with before, just to continue to mix things up. Helps you get to know everyone else in the class a little bit better. It's going to be important for projects. But nevertheless, so starting at the exercises actually start at line 62. And so the struggle here is to start to be able to communicate with another person what these terms mean. So when you see function with no parameters, you know what that is, and you can both agree on what that is, etc. and so on. The sense of humor that is in this document is not my sense of humor. If you are having trouble syncing your repository, let me put this on Slack right now to expedite the process. So mobile development 3, just take this puppy and drop it over. Unless somebody already put it. Okay, so this is a file right here. If you're having trouble with Git, remember to commit first, sync, merge, sync, etc. Just grab this file, open it up, and go for it. You're going to want to copy it, as usual, into exercises O's. I forgot. Sorry. So, whenever you get a chance, make sure to copy it into exercises less than 5. So for now, just use the zip file and copy it to your desktop or some other innocuous place. Okay.
Where's the zip file?
So I think it's going to have to be 30 minutes. But that's okay. All right. Vera, let's go for it. All right. Read it before? Have we gone through all combinations yet? I don't think so. I'm sorry? Oh, if you have it, it's in lesson 5, this one, homework exercise playground.
Did you get this?
Lesson 5, homework exercise playground. So what we're actually doing is the second assessment. The second assessment is entirely wrapped up in an app, and which is not where we are. And we're redefining the second assessment in terms of Swift only. So I think what's going to happen is we're going to give you these two playgrounds to start with, and see where you are and how well you're doing. And then have a declaration of the official assessment. It's like, make sure you complete those playgrounds, like beginning to end, and then submit them. But the second app is kind of funny. It's like the previous playground wrapped up in an app, which just doesn't make sense. So it's really funny. It's really funny. It's like all the control flow work you were doing. It's like the app is the way that assessment is written. It's like all the same exercises, but it's just like make a button that displays this in a label. And I'm like, we haven't gone over like a couple of things that you need to know first before we dive into that.
Okay. So nothing's due for Thursday is the gist.
You should try to get this done.
This one.
You should try to get this done for Thursday.
This one and then the other one, or just this one?
No, the one that said the one.